Yeah, I've started the recording. Thanks, Stan. Okay. Right. So, anyways, guys, I'm quickly just telling you all this. I'll take a separate, in a separate class. Yeah, I know. In a separate class, I will talk about all of these again. Just, just these things are important. A cell is represented. Second. Yeah. A cell is represented like this. A battery is represented like this. And a bulb is represented like this. And a resistor is represented like this. Okay, and power flows from the longer side to the shorter side. So if my circuit is going to look like this, for example, just a simple resistor circuit, then power is going to flow or current is going to flow in this direction. Yes, positive to negative. That's right. Okay, so today we might touch another topic that will change this basically, but don't think too much about that. Okay, I'll come to that. So anyways, a diode, if I put this in a circuit from positive to negative, I put the diode like this. This is how a diode is represented. 1 second, I'm going to put this. Okay, yeah. So now this is how the diode is represented, and current is flowing from positive to negative. So means the direction is like this. So you see, direction of current is in the same direction as the diode, so the power will flow. That's basically the function of a diode. I think now all of you know that, and it's super simple. Okay, I'll leave that. Okay, guys, what is this now? I'm sure all of you know it, but I'm going to explain how it works again. Exactly. Yeah, but I think few of you requested this last class as well, that just a quick explanation of this again. That's okay, Omar. Okay. So basically, let's see if I can zoom in a little bit. Oops. Okay. So the way a breadboard works is basically all of these horizontal rails are connected to each other. So anything that I put, if I put wires into these holes, they are going to get connected to each other because there are metal strips like this under the holes. You see, and this is the pattern basically in which they're connected. So if you look at the first row, let's go back to the previous one. Nope. Okay, so if you look at the first row, like row number 30 for example, A, B, C, D, E, all 5 of these are connected to each other. Same thing all the way from 1 up till 30. And then you come to F, G, H, I, and J, and you would see the same kind of connection there. But these two sides are not connected to each other. Does that make sense? So anything that I put into my breadboard, so I've got my breadboard here. Okay. Wow, I can't even see my picture. Yeah. So I've got my breadboard here. So anything that I put in this row, in this whole row, like this, gets connected to anything else that I would put in the same section. See, look at this. Look at that. So these two are now connected to each other, assuming they're two separate wires. Okay, super simple this is. And so this is like the main region of the breadboard. That's like this. Now when you come to the sides, which are the power rails, yeah, that's a jumper wire. So when you come to the side rails, these two rows are connected to each other. Sorry, not to each other. The whole row, all dots are connected to each other. See, you can see that here. You'll see that the whole row, all these dots are connected by this metal strip. Does that make sense to you all? Super simple. Like I don't remember. A few of you had doubts. Does anyone not understand like breadboard? It's very simple. When you actually, best way to practice it is think of some circuit and just make it on the breadboard. How do you connect E and F? Oh, okay. So if you want to connect E and F, assuming you need more space on your breadboard, what you're going to do is you're going to, 1 second. You're going to take a jumper wire from E and plug it into F. So like I've got E here and F here, right? So I'll plug a jumper wire into E and I'll connect the other side to F. Look at that. So like this, now both these rails are connected to each other. Stephen, we are building on to get to those robotics thing. Okay. And yeah, these are all basics that you will need to build robots. You can't just directly go and put things together and make a robot. They all have like, you know, the simple components with which robots are built, and we're learning about those. Prototyping something is very important before you actually go into making something, right? So this is what we're trying to do. We're learning how to make prototypes and like build small components that we later put together to actually build robots. So like today, when we're going to be talking about sensors, we'll learn about different things that help circuits see or know what's in their environment, right? And that is something that's really important that robots need to do. They need to know what's around them, and that's just that is why we basically are learning all of these basics and paying so much attention to them. Make sense? Okay, so I think everyone's understood what breadboard is, and this was your homework question, by the way, for those of y'all who did not. I think no one received it. Okay, so yeah, this was a voltage dividing circuit, but the challenge was to have an input voltage of 9 volts and get an output voltage of 3 volts. Okay, so the way you would do this is 1 second. Yeah, I know you all didn't get it. I will quickly draw this for you all just to show you all what it is, then you all can do it on your own later. I think more people just joined in. Oh, you want? Okay. I'm quickly going to talk about the voltage dividing circuit. Don't worry. Okay, let's do a short explanation first then. So, like how we discussed last class, a voltage dividing circuit is basically a very simple circuit that uses two resistors to divide the input voltage. So, whatever charge is in the battery, that is your input voltage, right? So, like for example, you connect a 10-volt battery to the circuit, so the input voltage for the entire circuit is 10 volts. A voltage dividing circuit uses two resistors to divide that voltage into basically to divide the voltage. And the way it does that is it divides it as per the ratio of one resistance to the total resistance. So okay, what that means is, though that sounds complicated, is if one resistor is 1 ohm and the second resistor is 2 ohm, okay, so the total resistance is in the circuit 3 ohm, right? 1 second. Yeah. So it's just like your fractions. So your total resistance will be 3 ohm. So now your 9 volts will get divided into 3 parts. Okay. And the amount of volts that each of the resistor gets depends on the value of its resistance. Does that make sense? So if my input voltage is 9 volts, it's going to get divided into 3 parts. Okay, because our total resistance is 3 ohm, and we are going to, and because one is 2 ohm and the other one is 1 ohm, one is going to get 2 parts and the other one's going to get 1 part. So one will get 6 volts and one will get 3 volts. Did everyone understand this? Is there anyone who didn't understand? Yep, I think all of you got it. Yes? Okay. Guys, what's with the question marks? If you have a question, then ask me. Okay, cool. So basically now we're gonna try and Ghana, what did you you didn't Ghana, were you there in the last class? No, I think that's why. So I would encourage that you watch the recording, and actually guys, watch the recording, because I spent at least 30 to 40 minutes explaining this. So it's not something that I can explain quickly. It's something that you need to break down and understand using like an analogy or something. So I really recommend that you guys just go and watch the recording. Okay, I do not email the recording to you all, but I've put it on the Facebook page, so you all can find the recording there, and I'll also email it after this class. All right. Okay. All right. But right now, for those of you who were there last class, I will just show what you all were supposed to do as your homework, and then you all can do it, as I'll try and make sure you'll get the circuit today. Okay. So this is basically, very simply put, the kind of circuit you had to make. A very simple voltage dividing circuit. You don't need the LED here. See, basically what we are doing is we're taking a battery, a 9-volt battery, different colors because I want it to look good. What? Oh, okay, right, makes sense. No, I'll read out the diagram because so your diagram is basically, okay, this is what your diagram looks like. Right, so this is what your diagram looks like. This is the positive of the battery, this is the negative. This is the positive of the voltmeter, this is the negative of the voltmeter. Okay, so first we connected the positive of the battery here. Look at this, the whole rail becomes positive, right? Because that's how a breadboard works. Okay, and this is the negative of the battery that's connected here. So from the positive of the battery, you see, follow this line. Positive of the battery is connected to one end of the resistor and the positive of the voltmeter. So I connected the positive of the battery, here. So this whole rail becomes positive, right? Yes or no, guys? Yeah. So this whole rail becomes positive, and then the positive is connected to positive of the voltmeter and also to one terminal of the resistor. Okay, then from the resistor, you can see in the circuit, the middle junction, the middle junction is connected to another resistor here, and it's also connected to negative of the voltmeter. Look. Wow, wait, no, I'm going to make this look good. That's it. No. Nope. One second, and this is going to be orange. Okay, so this is our decent looking circuit. But see, now we have the middle junction of the two resistors. One is that is connected to negative of the voltmeter, and the other end of the resistor is connected to negative of the battery. Does the circuit make sense? What I've done on the breadboard? All of you will understand? Yeah. So now the challenge that was mentioned in your homework question, and let me stop calling it that, in the question was that your input voltage is going to be 9 volts, but your output voltage has to show, that is the voltmeter has to show 3 volts. Right. So what you have to do is, okay, first to tackle a question like this, first you have to find what part of the hole, here the hole is 9 volts. So what part of the hole is 3 volts? So 3 volts by 9 volts means it is 1/3 of the hole, right? So the resistor, the output voltage is one part out of 3 parts of the hole. So now your hole has to be divided into 3 parts, means whatever your resistance. So you can say that the sum of the resistance, to keep calculations simple, we'll take sum of the resistance as 3 k ohm. Okay, so I'm going to select that. I'm going to make I'm going to leave this one as 1 ohm, and I'm going to leave 1 second. Nope. I'm going to make this 2 ohm. So now see, the total becomes 3 ohm, means the whole is getting divided into 3 parts, and now we want one of our resistors to get 1/3 of it, means it has to have 1/3 of the total resistance, means one will be 1 ohm and the other one will be 2 ohm. So the total is 3 ohms and one of them is 1/3 of the total. It's as simple as that. So now you can see when I run the circuit, it shows 3 volts. Guys, does that make sense? Tell me in the chat. Then I'll move on. Oh, okay. So when you're when you're measuring the resistance of a resistor, that is how much it can stop the flow of current, you use something called ohm as the value. It is the SI unit of resistance. Yes. So just give me a second. Yeah. So now if a resistor, for example, can hold back certain amount of current, then what do you mean? I didn't get you. What do you mean the value of resistor in the breadboard? So it's basically a measurement unit. Now if you look at for example length, so you say you have a 15 centimeter scale, like how you're using centimeter to measure length, similarly you use ohm to measure resistance. Simple. It's the unit of resistance. Okay, so now guys, a trick question for you all. If I want to make this 3 volts, I want the 3 volts to show, for example, 4.5 volts. What should I make the resistances? Okay, so the total should be 2 exactly. So they have to be equal, right? So one of them will be 1 ohm and the other one is also 1 ohm. And see, that changes immediately. So that makes sense, guys. And I clear the circuit. So this is basically a voltage dividing circuit. Now, I'm not going to do the potentiometer bit because we're going to do the LDR and all now. Okay, now coming to a somewhat interesting concept of atoms. So, how many? I'm guessing most of you all will know what are atoms, but for those of you who don't, I'm going to explain this to you all. Now, basically, everything that we see around us that takes up space and has mass is matter, right? You know that everything that takes place, that takes space and has mass is matter, be it anywhere in the universe. Now, matter is made up of simple building blocks called, okay, Dev, once is enough. Matter is made up of simple building blocks called atoms. Atoms are thought to be the smallest units or building blocks of all matter around us. So anything that I pick up is built up of really small particles called atoms. And for a very long time, so guys, a little bit of backstory on this is it was actually an Indian researcher who had, I think he had it was while he was eating something that he realized that he can break this down into smaller pieces, but there must be something that cannot be broken down any further. And he had named atoms in Sanskrit basically. I think atom, it was some, I don't remember the name exactly, but it was related to a Sanskrit name for this. And after that, there was a Greek philosopher who had discovered the same thing, saying that, who basically popularized this theory, saying all matter around us can, everything that we have around us probably has something really small from which it cannot be divided further. And he named it atomos after the Greek word. So he named it atoms after the Greek word atomos, which means indivisible. So atomos means indivisible in Greek. So it was the Indian guy, but because the Greek philosopher made it popular, he's credited for it. Yes, Indian guy found it first. That is what I've heard. Okay. Yes, he's a stealer. Okay. Oh, is that his name? Acharya Kanad? I do not know. If that's the name, thank you. Yes. Okay, guys. So basically, it was a Greek philosopher who called it atomos, and called it atoms from the Greek word atoms. Okay, and atoms basically are the simplest or the smallest particles of matter. It's something like modern. I will check on the whole name coincidence thing. I don't remember that exactly. Maybe it was called something else in Sanskrit, and I remember the Greek part for sure. So, bit unsure about the Sanskrit thing. I'll check on that for you. Anyways, so basically, the smallest part of matter was basically atoms. Up till very recently, it was thought that there is nothing like atoms cannot be divided further. But now they have realized that even atoms are built up of three different particles and can be divided further. That are neutrons, electrons, and protons. So the structure of an atom is what you see on your screen right now. The very smallest building block of matter, an atom. This is what an atom basically is said to look like. So no one has seen atoms. It is almost impossible because it's that small. It is impossible to see atoms. But they have used some other techniques and experiments to find out what they can look like, and this is the conclusion they have come to. This is the most widely accepted structure of an atom. Okay, so basically the center of an atom, the nucleus, has equal number of neutrons and protons. Okay, they're called nucleons, but ignore that from. So what do you think? We all know protons have a positive charge. What about neutrons? What charge do they have? Tell me, guys. Anyone else? Two answers, neutral and negative. Okay, that's right. Sean is right, few others are right. Okay, so contrary to popular belief, neutrons have no charge. Electrons have a negative charge. And protons have a positive charge. Okay, so now there are different types of atoms, different elements and different types of atoms based on the number of protons and electrons they have. Okay, so in a neutral atom, the number of protons and electrons is the same. But let's not go there now. Basically, the different types of atoms based on the number of electrons and protons they have. Now, there are certain configurations, means certain number of electrons that an atom, be it any atom, can hold very stably, that it can hold comfortably. Okay, so like if I think of, let me think of something. These two motors as electrons, I can hold two electrons very comfortably. Yes, like example, if I was an helium atom, so my nucleus can hold two electrons very comfortably. But if I try to give myself more electrons, it's going to be difficult for me to hold on to them. Okay, and I'm going to be unstable basically. So, reason I'm telling you this is basically we're going to come from this to start talking about metals and conductors. Now, you remember since the beginning of when these classes have started, I've been talking about power carriers in circuits. Remember that? So like one side, yeah, we have to talk a little bit about chemistry so you understand physics. Then we'll do math also. That's STEAM, you know. There's science, technology, then engineering and math. So science, that's important. Okay. Yes, exactly, Ayman. So the power carriers that I've been talking about from the beginning of the classes are actually electrons. So I'm clearing all of this and I'm going to explain this to you all really quickly. So in a battery, And okay, you all have to listen to this carefully because this is very confusing. You know, from the very start, we have been saying that power flows from positive to negative because of a difference in power carriers, right? Right? But in a battery, what actually is happening is one side has more electrons than the other side. And electrons have a negative charge. So the side which has more electrons is going to be negative, right? So the negative terminal of a battery generally has more electrons than the positive side. So when I connect these two with a wire, what happens is, because one side has more electrons, the electrons start flowing in the circuit. See, the electrons start flowing in the circuit. My yellow color electrons. Till there are equal number of electrons on both sides. But see what is happening. Electrons are flowing from negative to positive, right? Isn't that the case? But what we have learned is power carriers are flowing from positive to negative. Isn't that a conflict? Right? So now the reason this conflict arises is because when the concept of electricity and power and all of that had come along and circuits had come along, they did not know that something like electrons exist. So for them, it was power carriers. And they thought the positive side has more power carriers. And what they assumed was power carriers were flowing from positive to negative. But later, when they discovered that that it is actually the electrons on the negative side that are flowing from negative to positive, they thought we've already been using the old system. Why change that? So now what we've done is we've come to basically having this sort of a conflict. But when you're dealing with circuits, by convention, you say that power flows from positive to negative. I know it sounds a little bit confusing. Okay, so because of old practices from when electricity was made, it is believed, and everything like circuits are designed assuming that power flows from positive to negative. But you know, like an insider secret, you should know that it's actually electrons flowing from negative to positive. So actually current is flowing from negative to positive. Okay, so the way you say this is, so the way we term this while we're talking about it is that current flows from positive to negative, but electrons flow from negative to positive. Does that make sense? They were explained why. So this was basically when electricity was discovered, and they started dealing with it. What they realized was that what they thought or they assumed at that point was that that electricity flows from positive to negative. And now when they found out that something called electrons exist and it's actually electrons flowing from negative to positive, they didn't bother to change it. They're like, we'll just believe in the convention and we'll follow that. Because, you know, so many grids have been set up using the old thinking, and for them to change it, it would be a lot of like a very long process. I guess I don't know, they just decided not to do it. So we say by convention means, you know, some beliefs of the past. By convention, we say that, yeah, so current flows from positive to negative, but electrons flow from negative to positive. Yeah, that's right. It's as simple as that, Razak and Merlin. Okay, so now let's talk about how current or electrons actually flow in a circuit. Now, how do I explain this? Okay, so now an electron is infinitely small, right? I already told you that. Like, you know, you can take a grain of sand, and a grain of sand is going to have billions of electrons. So that's how small an electron is. So you firstly definitely cannot see it. So now, for something that's that small to travel just from here to here can take hours. It can actually take a very, very long time. for an electron to travel from this point to this point. So, but when we turn on the light, if I were to press my switch now, the bulb is going to turn on immediately, right? An electron microscope can still not let you see electrons in the structure of an atom. Right. Okay. So basically, you'll see, but you can see now if I were to take a battery, I have a battery here and I have an LED. Let's see, burnt LED. Oh no, I'm going to burn it. See, I have an LED here. Wow, guys, I have burnt LED. 1 second, I need an LED. Finishing my LEDs, burning them. Oops. Just a second. Yeah. So you'll see how the LED is on. Now see, you can even if I were to connect this to a very long wire, like what is this? Just a second here. Right, alligator clips. So see, I'm connecting my LED to 2 wires and I'm gonna connect. See, the wire is long, right? And excuse me, and I turn this on. See, the LED turns on instantly, even though the wire is long. 1 second, Ishan, I'm not explained anything yet. I'm coming to that. Wait. I'm just trying to prove a point to you all. What is happening? See, the moment I touch it, it turns on. There's like no time delay. But what did I tell you all? An electron takes like very long time. For an electron to travel this much of distance, it can take a couple of minutes or even hours, like for a longer wire. So for me to think that when I connect these two ends, it is an electron from this side is going to the LED and coming back. That cannot actually be happening, right? Because it's not that slow. This is happening instantly. So what actually happens is when you connect this in a circuit, the wire itself is made up of hundreds of these atoms. Not hundreds, billions of these atoms. I'm going to give me a second. I want to draw this properly, okay? Only then you will understand. It's billions of these atoms. Okay, this is like super magnified, but just try and understand the concept. So I'll tell you 1 second. I'm connecting this to my battery here. 1 second, need to show electrons also. Guys, these are just, I'm giving you all examples. Don't actually think that it's going to be like this. I just want to explain the concept to you all, okay? And I'm going to connect this to a battery. So now one side of the battery has more of these negative ones, right? Yes or no? So one side of the battery has more of these negative of these electrons. So it wants to get rid of them. Okay, Dev. Okay, Advik, I get it. That's your thing. It's very slow. And Dev and Advik, don't spam. Okay. Now listen. Do you all see the circuit here? 1 second. I need to clear something with my screen. Yeah. You'll see. So this is basically, for example, a battery where one side has more electrons, other side has less electrons, and we're connected a wire with many atoms. Each atom, for example, is holding 2 of these electrons. Okay. Now what the battery wants to do is it's going to pass its electron because it has more. So the battery is going to pass. I'm an atom. The battery is going to pass one of its electrons to me, and now I have 3 electrons. Guys, why are you all raising your hand? Do you all have a doubt? Kashinath, Arjun. Anyways, so now I have 3 electrons, and you remember what I said? If I have 3 electrons, I become unstable, right? It's too much for me. So what I do is I pass my extra electron to the next atom. And he is going to pass it to the next person. Right? And it is going to be this passing, continuous passing, or this kind of vibration that's going to take the electron, basically, not like, basically, I'm going to give one of my electrons to this, the next electrons, it's going to give it to the next atom, and so on, until it gets to the positive side, and they both sides have an equal number of electrons, and the process stops. Does that make sense? So this is basically how current is flowing in the circuit using electrons. Now I'm sure you'll have doubts, so ask me. Do you understand basically how electrons, it's like a chain, yeah, you can say that. See guys, the actual chemistry of this is where I'll have to talk about, you know, like their electronic configuration and how they have one more than the noble gas configuration, so it can easily get rid of one electron and pass that out, and some cannot do that. Okay, so now I'm sure you guys are wondering, how does the concept of insulators and conductors come here, right? Yes or no? All of you know, they're like insulators can allow power to flow, conductors cannot. Okay, so now think of it like this. Very simply, think of it like this. Now I am a conductor, so I can take one more electron and pass it on. But if I was an insulator, okay, just think of an insulator as a very, let's just say, okay, now see, no, yeah, there's classes on until like 1:30, 1:45 around that time. Okay, so now if I'm an insulator, you can say I'm a very grumpy kind of an atom who is not going to accept the third electron at all. I'm going to be like, I cannot take this, don't give it to me at all. So the battery does, that's just, you know, a property of the electron, of the atom. Okay, so it is not going to take the third electron at all. It's going to be like, you keep it to yourself. Yeah, his boss said. So it's not going to take the third electron at all, and that is why electrons will not flow in a insulator. So my wood table here, I can connect, look, instead of connecting it directly, I can keep my battery here and I can, you know, connect it anyhow I want, but this is, the LED is never going to light up, because insulators do not allow current to pass. No, insulators do not allow current to pass. Conductors allow current to pass. Why would I say insulators allow current to pass? When did I say that? Yeah, my LED is on. When did I say that, Merlin? Is the concept clear to everyone? Does everyone understand how that works? Okay, good, right. You know that conductors conduct and insulators do not. Right. So it's, as you can say, it's as simple as this. Now, 1 second. I have to. Okay. Excuse me. So I gave you one example of a type of insulator, right? That you can say is going to hold on to two of its electrons properly, and it's not going to accept a third one at all. Now, in some cases, what happens is, the atoms have one less electron, then it can hold comfortably. So in that case, if someone gives me one more, I can hold on to both very nicely, right? But I will not pass it on. Does that make sense? Somewhat make sense? So you can say that's another type of an insulator. Basically, it's not going to let electricity flow, but in this way. Okay, guys, see, the actual chemistry is very different. Like, it's much more complicated, but I just want you all to understand the concept of simply how this is happening. So I can talk about sensors later. Okay. So now basically resistors, you remember how resistors, I've been giving you all the example of a narrower road. So the way they narrow the road, you can say, is the difference in basically, yeah, that's fine. The difference is basically in the way they pass on the electrons. So if they pass it on, like basically they can accept, like if they can accept, they can, you know, pass on two at once, or like, not, it's like bad analogy, but like basically if you can pass it on faster, then it's a better conductor. But a resistor basically you can say will pass it on more slowly, like the material is like that, the atom is going to be like that, and then the number of such atoms and the way that these two atoms are mixed and everything, that makes up a resistor, basically a resisting wire. So a resistor basically makes this process slower, and it depends on the property of the material. Okay, now we're going to be talking about wow, what an amazing drawing. I'm going to screenshot this. Okay, let's go. Next slide. Okay, now let's come back to our sensors for a while. 1 second. So last class, what we did, we all know what sensors are now. I don't think there's anyone here who does not know what a sensor is. Sensors are basically that helps circuit know what's going on in their environment. It helps them either find, either measure or take an action, or like detect if something, an external factor is changing. As simple as that. So now there are different kinds of sensors that can detect different things. So in essence, there are 4 different kinds of sensors: light, heat, motion, and moisture. Okay, so light sensor can detect the amount and change in the amount in the light around it. A heat sensor can detect the temperature or how much heat is around it. Motion can detect if something around it is moving, and moisture is how wet something is, basically. Okay, now how moisture sensor works is going to be for next class, but today we are going to be talking about a light, heat, and motion sensor. Okay, so let's get started. We will come to that. Jatin, wait, we'll come to that. Okay, I know it was asked in the quiz, and that was because I planned to cover it in the last to last class. So now what you have on your screen is something called an LDR. Okay, an LDR is, I think someone said it, light dependent resistor. Oh, that's bad in writing. One second, guys. Okay. So an LDR is a light dependent resistor. One second again. Okay, so an LDR, yes, we did. I'm going to be talking about how an LDR works now. So an LDR is made up of, an LDR is also called a photoresistor. And it is a type of resistor, but it is made up of a different kind of material that changes the value of resistance based on the light that is incident on it. Okay, so now if we were to think of this back, if you were to come back to the whole atoms ka principle, atoms in a line ka thing, and I'm going to draw something quickly again. So we've got an atoms ka thing, and we've got my 2 electrons here, and I'm getting my 3rd electron and I'm passing it. Now, what if the way or the speed at which I pass the 3rd electron, or like the 3rd power carrier, dependent on the amount of light that's in the room? right? So that is basically what is happening with the atoms in, sorry, with the electrons in the atom of a photoresistor. Okay, you know what, guys? I'm not satisfied with how I've explained this. I'm going to explain this bit again. Okay, for this I'm going to come back to the whole atoms ka concept for a second, and I'm going to talk about. Okay, guys. I know a lot of you all aren't in like 8th and 9th and all of those grades, but I'm going to come back and explain atoms a little bit more. And right now, so you'll understand this better, because I cannot explain photoresistors without explaining this part of atoms. Like, I use the analogy, but I'm not convinced with it myself. So don't expect you all to understand. Okay, let's go back to our diagram for a minute. Guys, it'll take 2 minutes. It's important. It'll help you in your chemistry at school as well. Won't have to do it later. Okay, so see, uh, this is basically the structure of an atom, like I told you all. Now, an atom normally, it's not as simple as this. Let me get one more picture. This is basically a very bad picture. That is the problem. No. Okay, you know what? Let's get this. I can at least explain something with that. Okay, let's look at this. Okay, one second. I'll explain this to y'all again. So again, same thing. We got our protons and neutrons in the center, and we have got our electrons on the outside. Okay, so now what these are? What happened, guys? Listen. I'm explaining. This is also what you'll see here is also an atom. But remember how I told you all there are protons and neutrons in the center and their electrons in around. Adi, that's okay. I'm simplifying it as much as I can. So this is just the structure of an atom. Yeah. So now these electrons are around the atom, around the nucleus in round paths. They're present in round paths called orbits, but ignore orbits for now. Let's just call it round paths. Okay. And each round path can hold a maximum number of electrons. Okay, so like the first round, for example, can hold maximum. Guys, this is 6th and 7th grade chemistry. So if you're Omar, I'll end it once I'm a little bit satisfied with the explanation. I don't want to cut short on this. I mean, if you all are tired, then you all can tell me. If those of you all are fasting. Is this a sodium atom? Yeah, this is a sodium atom. Yes, 11 electrons. Smart. Yes. Okay, I'll wrap it up in a while. Anyways, so you have orbits. Basically, these are paths around the nucleus in which electrons are present. Okay, so like the first path can take 2 electrons, second one can take 8 electrons, for example, and like let's just say for now that third one can also take 8. Does that make sense? Okay, so now think of it like this. For an atom, for any atom to be stable, it has to have 8 electrons in the outermost round, in the outermost circle. Guys, this is, I know, a little bit complicated chemistry, but try and understand. Okay. But in some cases, there are, like, for example, either more or less than the 8. Sorry, there. 1 second, guys. Okay. Yeah, I realize I'm not doing a good job at explaining this. Guys, what should we do? You know what? I'll get a video for you all to understand this better. I think I've kind of messed up with this explanation. So chemistry explanation. I don't think you'll understood. Let's just do some basics. Yes, that makes sense. Great. Yeah. Okay. So the way this works is basically the resistance of the photoresistor changes based on the number of electrons that it has. What am I doing today? Yeah, sorry. So the resistance of this material changes with the amount of light that's incident on it. And it's basically, you can say, okay, Hussein. So you can say that in like how in a potentiometer, turning the dial would change the resistance. In a photoresistor, the light that's incident on it changes the value of resistance. So if we were to go back to this circuit, what we can do is we can change the one of the resistors with a photoresistor. Look at this. So this is basically a variable resistor, and when I turn this on, see, and I change the amount of light, its resistance changes, and as the value of resistance changes, the voltage across it also changes. 1 second, I'm going to take a multimeter, see if I can use that to measure the resistance. Okay, turns out I can't measure resistance directly. Right. So you can see as the amount of light changing on it, following on it changes, the voltage across the resistor changes as well. It's as simple as that. Now let's come back to that. So next thing is something called a thermocouple. Okay, so a thermocouple is basically like it's something that is used to measure temperature. It's called a thermocouple, can't you? It's written on the board. Thermocouple. RTD will come to next. It is made up of two metal sheets. Okay, that's right. So the way a thermocouple works is it has two, 1 second, this is one and this is another one. It has two strips of metal that are connected at the tip of it. Okay. 1 second, that are connected at the tip, like you can see in the diagram. Okay. I'll play the video in next class. I'll have to find it. Wait. I'll show you a thermocouple on Tinkercad after this. But listen. So now the way a thermocouple works is you can think of it as two metal conductors that are connected to each other. And what happens is when you apply heat on one end, so a blue color flame, very weird looking blue color flame here. When you apply heat on one end, what happens is the power carriers that are on that end, or you can say the electrons that are on this end, they automatically move to the other end. They move to the cooler side. So they will move, the electrons will move to the cooler side, that is away from the heat, to this end. Clear? Let's just use this. So I'm applying, let's see if I can draw a flame. We've got a campfire here, guys. This is good drawing. Now we know we are applying heat on one end. So what happens is the electrons from this end are going to flow to the closer side. Okay. So what happens is the electrons from one side are going, it's conduction, are going to flow to the other side. Now, if these are two different materials, the amount of electrons that will flow to the cooler side is different. Okay, so in some metals, electrons will flow more easily than the others, and then in others electrons won't flow as fast. So what does that mean? If electrons are flowing more fast on this side, means there'll be more electrons here, then there'll be electrons here. Yes or no? Adi, it's going to be simple. Just listen. When you're applying heat on one side, electrons are going to move to the cooler side, right? So now electrons, they're two different materials. Through one material, electrons will flow faster, and through the other material, electrons will flow slower. That's exactly right, Ayman. So now if there are more electrons on one side and lesser electrons on one side, you can think of this as basically becoming a battery. Yes or no? It basically becomes a battery, right? Because one side has more electrons than the other side. So it becomes a battery. So now what we do is we measure the potential difference across the battery. I mean across these two. Okay, Advik, are you just using Google? Anyways, so you can say that the end becomes a battery, and if it becomes a battery means we can measure the battery's voltage. Yeah, one second. So what we do is we measure the amount of voltage that is in our said battery, and that tells us. And what we do is if the heat was more, then more electrons would have flowed, and if the heat is less, then lesser electrons would have flowed. And we calculate that difference for different temperatures. One second. See, so guys, basically what happens is with a difference in temperature, okay, Ryan. I mean, guys, if you're just copy pasting things of Google, then don't waste my time. I'm closing the chat. So what happens is, as the temperature changes, there is a difference in the number of electrons that are flowing to the other side, and because of that, you can say there's a different voltage in each case, in each of the metal strips. That causes a different potential difference depending on the temperature. Does that make sense? So what we do is we calibrate for any two materials when they're making the thermometer, the thermocouple. They take something that they know is at 100 degrees and at a 0 degrees. Okay. So like for example, I know that this boiling water glass is at 100 degrees. Then we will dip the thermocouple in that. One second. Can you all hear me? Okay, so basically what happens is there is a difference in with a difference in temperature, there's a potential difference that is generated on both these in both of these ends. So if we'll take something that we know is at a 0 degrees and we'll dip the thermocouple in it, and we will take the voltage reading, and then we will say that, for example, voltage 1 second, we'll say voltage 0.1 millivolt. By the way, the potential difference will be very, very, very small. Okay, it'll be super small, just been enough for a voltmeter to measure it. For 0.1 millimoles, the temperature was 0 degrees. Then we'll be like, for 100 degrees, the voltmeter reading was 0.25 millivolts. Okay, and then we will take, basically we'll form a relation that will help us tell that depending on the number of volts, what is the temperature. Does that make sense? Does everyone understand that? 1 second, guys. Make sense, everyone? It's super simple. That is basically what is happening. Okay, let's go next slide now. Okay. Second one is RTD, your resistance temperature detector. Whoever was obsessed with it. Next slide. So, guys, and the resistance temperature detector is also called an RTD, and it performs the same function as a thermocouple. That is, it measures temperature. Super simple. It's in the name itself, right? It's a temperature detector. Right? Everyone understands. So, like, that's basically what it does. So now how does it do it? That's important. So we learned one way in which an electronic circuit can detect a temperature, that is with a thermocouple, by changing that. Now, you remember how there was a special material where depending on the light incident on it, the resistance resistance changed. Yeah? So now a resistance temperature detector is made up of a special kind of wire, okay, in which, one second, uh, before I come to that, you all should know this. Every material, okay, so any material, literally, actually every material, every conductor, its resistance changes with change in temperature. You understand that? So if I take a copper wire and I get a certain resistance value from the copper wire, which will be very low, as I heat it up, the resistance value will increase. Okay, guys, I'm going to use my electrons analogy here again to explain why this happens. So now I am an atom. I have all my brother and sister atoms around me, and I am holding on to my electrons. Okay, so now what happens is when I start getting heated up, or when I'm burning, I find it hard to hold the electrons. Okay, so I keep throwing them around basically. Right? One second. Let me get one more thing. Wow. Just give me a second. I want this to be a better looking demonstration. One second. Uh-huh. Okay. Nope. Okay. So 3 electrons, you can see. Okay. So as I get heated up, I start throwing them around because I'm getting burned. Simply, you can say that. Okay. So in this condition, so like I've got 2 and I'm throwing them around. And in this condition, if someone gives me a third electron, I'm going to start throwing that around also before I pass it out. Who kicked you out? Do you all understand? So what happens is, do you understand basically how, yeah, I think I want all of you to understand. Yeah, so the random movement, basically the random movement between these electrons increases because of the heat. So that is why that order of passing on the electrons slows down. And that is why resistance increases. It's as simple as that. I think everyone must have understood. Got it, guys? Let me know if you have any questions. Dave, what do you not understand? No doubts? Okay. So, you remember now, what kind of a circuit can measure change in resistance? Tell me. Okay, Mohammed, ask me a question. Okay, Hussein, if you have a question, just put it in the chat. I'm going to wait. That's not a question, Mohammed. Fine. I'll tell you this very briefly again. So, atoms have a certain order. Atoms in a wire have a certain order that they're going to get an extra electron, they're going to pass it on. Right? That helps them basically. That basically helps the this current to flow. But when I heat them up, the randomness increases. They start randomly, the electrons start moving randomly around the atom. What do you mean the material matter? Oh, so like the reason the material, who is kicking you out, Kashinath? See, the reason the material matters is because some of them will show less random movement, some will show more random movement. Okay, so what happens is, tell me if you understand. So there's random movement because of the heat. So if there's random movement, that order of passing on the electrons is disrupted. Right? So because that order of passing on electrons is disrupted, the resistance increases. So in most conductors, the resistance and temperature relation is something like this. Yeah, Hussein, tell me. Yes. One sec. Okay, so oh, wow, stop using Google, guys. So in most conductors, the way the relation increases is like this. As temperature increases, the resistance increases like this. But there are some special materials, like for example, platinum, where this increases, the resistance increases like this. So for every temperature value, there is a proportional increase in the resistance. Okay, Mohammed, if you have a question, then ask me now. That does not have to do with me playing FIFA. Guys, you'll understand. So there's some materials where for equal increases in temperature, equal values of resistance increases. Okay, everyone make sense? So what we do is, okay, now tell me what kind of a circuit can measure change in resistance? Tell me guys, what kind of, yeah, I got it. Tell me what kind of a circuit can measure change in resistance? No, change in resistance. Exactly, a voltage dividing circuit. So if we put a resistor, I mean this RTD kind of a special resistor in a voltage dividing circuit, and we change its temperature, we can measure how much temperature is changing based on how much resistance changes. Omar, just 10 more minutes. Guys, does anyone have to go pray? Nope. Okay. Right. Uh, so have all of y'all basically got, you all understood how does the RTD work? Dave, you're asking me for the quiz today. I'm gonna actually see how much you're scoring on the quiz, okay? Because you all don't want to listen what I'm saying in the class. You want the quiz, and you're not gonna answer anything in the quiz. Okay. The last kind of sensor, because I want to be done with the sensors. Only then I can start talking about the Arduino and all of that. Right. So last kind of sensor is a motion sensor. Give me a second. Okay. A motion sensor is also called a PIR sensor. And I give me 1 second because I did not remember. Yeah. Okay. So a PIR sensor is called stands for a passive infrared sensor. Have any do you all know what infrared is? So infrared is basically a type of light wave. You can say it's a type, like it's similar to light in a way. It's a kind of it's a kind of radiation that you cannot see. Okay. So infrared type of radiation that you cannot see. And the way this sensor works is this sensor can see, like we cannot see it with our eyes, but there are sensors that can see this radiation. And our human body, as we, our human body emits heat, right? It emits heat in the form of these, basically this in form of infrared, like it emits heat, and that heat can be seen in the form of infrared radiations. Okay, let me pull up an image to show you all. Human IR. So a human will give out heat that will make him look like that. Do you see that? Or look at this example, for this one, for example. Yeah. So through these special kind of cameras, what is happening is, as our bodies are giving out heat, and this heat can be seen by these sensors in the form of infrared radiations. Now, an infrared sensor, basically, the way this sensor works is it is divided into, you see the center part. This center part is basically the actual part that can see IR radiation, and it is divided into two sections, 1 and 2. Okay. Sorry, give me a second. Okay. And what is happening is, when you are so both these sections are looking for infrared radiation, and one section is going to measure that there is, for example, this much infrared radiation, and section B is going to see that there's only this much infrared radiation. So the sensor will know one side has more infrared radiation than the other. So in a room, for example, it's going to see this side of me has more radiation than the other. Then as this person who's giving out the infrared radiation moves around the room, the region where the infrared radiation is present will also move. So one side will have more, this side will have more infrared radiation than the other. And this is basically used to detect, excuse me, yeah, and this basically, this transition helps. It's called a pyroelectric sensor also, but ignore that word for now. Stick to PIR. Guys, I'm not going to explain this again. So I'm going to explain this one last time. We've got our infrared sensor, PIR sensor, also called a passive infrared sensor, can see infrared radiation. Okay. So the sensor divides everything that it is seeing into two regions. We humans are giving out infrared radiation that the sensor can see. So it's going to see that there is a human with this much infrared radiation on this side of me. And then it's going to be like, there's no one here. So it knows there's a difference in the two places. Then as the human walks from this side to this side, it can measure that there is a change. And so it knows basically that as a person has moved, some movement has happened, and it can detect that movement. Understood? Hussein, I'm going to be done in like 5 minutes, like 2 minutes maybe. And that's how a PIR sensor works basically. And it has 3 pins behind it. I don't know, there's an image. Yeah, you can see the 3 pins here. One gets connected to power, last one gets connected to negative, and this one gets connected to signal. And there's a lot of internal circuitry, like you can see here. that turns the pin on and off, like it gives a signal 1 or 0 depending on whether the power in the circuit, sorry, depending on whether there is movement or not. Very simple. Done. Okay. Now, and anyone wondering what is this white thing on top? I don't think so. So this white thing on top, no, it's not a golf ball. The white thing on top is called a Fresnel lens. White thing on top is called a Fresnel lens. Fresnel lens. I'm written it down. A Fresnel lens. A Fresnel lens basically takes infrared radiations from 180 degrees and it focuses it onto the sensor. Hussein, I'm writing with a stylus on an iPad, so don't blame me. Okay? Get that, guys? So that is basically what this thing does. And I'm guessing by now everyone's understood this as well. We'll do transistors and Arduinos in the next class. Let's do quiz. Wait 1 second. Okay, join in, guys. This is your code. I'm going to put the link in chat. Okay, guys, if you're doing this, join in, and I'm going to switch off the music because I know you can't listen to music. Very thoughtful. Anyone else still joining? Expecting a few more people to join. I'm going to start it. Guys, can I start this? Okay, start. Okay, let's see how you guys do. Okay, guys, we got Jatin in the lead, then Ishan, then Kashinath. Okay, we got Ayman with first place. Then got Jatin. Okay, great. And yeah, your surveys. Yes, one second. Oh, we finished early today. No, guys, do the survey, please. Guys, do the survey before you all leave. Okay, guys, just do the survey before you all leave, alright? Thanks, guys. Yeah, I did that already. Do it again. Yeah, you all can leave once you're done with your survey. What happened, Razak? Oh, that's okay. It's fine. Doesn't matter. As long as you did the answers. Okay, thanks for doing the survey, guys. Hope you all learned. Guys, next class. Oh, wait, guys, next class. I'll have it around the same time. That's okay, right? Good. Is this time okay for the class? Tell me what time works best. Yeah, that's fine. Okay, I think next class there might be someone else who might. Next time there'll be someone else who will explain. Might not be me, like a guest presenter. So yeah, I look forward to that. Yeah, not Friday, Saturday only. One second. Okay. Yeah, no, not me. There'll be a guest presenter next class. 3 to 5 is difficult for me. It'll be 1.5 hours, right? Okay, guys, I'm gonna end the class now.
Bye, Rishabh. Have a nice day.
Thank you. Yeah, you guys too.
Can you send the link, survey?
Yeah, I sent it already.
Bye, Rishabh. Have a nice day.
Bye, guys.
Can you send it again?
Yeah, I sent it just now.
Okay, thanks.
No problem. Okay, guys, I'm gonna end the class, right? See you. Bye.